Okay, we're back with the second page of notes. They say notes continued at the top. And this is just more math review, stuff that you should have learned in probably elementary or middle school, but you probably haven't thought about it in a while. Okay, the topic for this lesson will be converting between fractions, decimals, and percentages. All of these number formats are used to represent numbers that aren't whole numbers, essentially, parts of numbers, okay? So we're going to start with probably the easiest, converting fractions to decimals. Any fraction can be changed to a decimal. I mean, you can take 1/2 and turn it into 0.5 very, very easily. To take a fraction and change it to a decimal, you have one step. All you got to do is divide and then follow any other instructions. So for example, change the following fractions to decimals rounded to the nearest hundredth. So we start off with 3/7. Very, very easy to do. Take 3, divide by 7 on your calculator, and you get 0.428571429. Now, we want to round that to the nearest hundredth. So because we're trying to round to the nearest hundredth, I'm going to write this out initially to the nearest thousandth. 0.428 tenths, hundredths, thousandths. Now I need to remember my rounding rules. This is the digit I'm trying to round. This is the number that's going to tell me whether the 2 stays the same or if it goes up to a 3. 8 is above 5. It's a greater number than 5, so that means that I'm going to round this up. So the answer would be 0.43. Okay? So remember, when you're rounding, you don't just go to the hundredth spot and say, okay, I'm done. It says round to the nearest hundredth. It might be possible to round that number up. Let's do 7/8. That gives me 0.875. 7 divided by 8. 0.875. We want to round to the nearest hundredth. That's this spot. Okay, same spot, two spots over from the decimal point. 5 is going to make this round up, so that's going to be 0.88. Now, if this had said 0.874, I would leave that off and it would just be 0.87. It wouldn't round up, it would stay the same. Converting fractions to decimals is very easy. Converting decimals to fractions is a little bit trickier, but it's still fairly easy. To change a decimal to a fraction, all you have to do is write the number given without the decimal as the numerator. So for this first example, 0.79, I would start off by writing 79. And it says as the numerator. Numerator, remember, means the top of a fraction, so that kind of gives me a hint that I'm going to be writing a fraction here. The denominator is 10, 100, 1,000, 10,000, etc., depending on how many decimal places there are, and then you reduce the fraction to lowest terms. This is the tenths place, this is the hundredths place. The last place is the hundredths place. That means I put 100 down here, and now I'm done. 79/100 can't be reduced anymore, it can't be simplified. Okay? So whatever the place is, if it's the hundredths place, you put it over 100. If it's the thousandths place, you put it over 1,000. If it's the millionths place, you put it over 1,000,000. Let's do example number 2. We have 0.003. We put the 3 in the numerator, and then in the denominator, tenths, hundredths, thousandths, I put 1,000. That can't be simplified, so that's our answer. 2.5. Now you have a couple options here. What I would probably do at this stage is I would write the 2 off to the side. Okay? Then I'm going to deal with the 0.5. 0.5 means I put the 5 on top in the numerator over, this is a tenths place, 10. And if you look at that now, it says 2 and 5/10. You have a nice mixed fraction. However, 5/10 you can reduce. 5 divided by 10 can be reduced to 1 divided by 2. So another way to write this in simplest terms is 2 and 1/2. And if you don't like mixed fractions, what you can do is you can change this to an improper fraction. The way to change something to an improper fraction is to start with the denominator, take the value of the denominator, multiply by the whole number out here, so 2 times 2 is 4, and then add the numerator, 5. And then write 5 over the old denominator, 2. 5/2 is the same as 2.5, as I can prove right here. 5 divided by 2 is 2.5, which is the same as 2 and 5/10, which is the same as 2.5. Okay? So that's not that hard either. It's a little tough to remember the rules. So we know that fractions and decimals are ways to represent something less than 1, or a part of a number that's smaller than 1. Percents are another kind of way to do that. A percent is just a ratio that compares a number to 100. The word percent means out of 100. Per as in like divide by, cent as in 100 cents in a dollar. Just like a decimal or a fraction, a percent just describes a part of a whole. If you want to change a percent to a decimal, it's very easy to do. You divide the percent value by 100, or you can move the decimal point 2 places to the left. Now, I have people forget this all the time, or they don't move the decimal enough places. So I'm really going to suggest that to change a percent to a decimal, you stick by this rule. Divide the percent value by 100. So for example, we have 34%. I'm going to take 34 and divide by 100, and I get 0.34. That's 34% expressed as a decimal. 2%, I divide that by 100, and I get 0.02. That's where people screw up a lot of times. They'll just think it's 0.2 because they don't physically move that decimal point 2 times and add the zeros in. So I'm recommending whenever you're trying to convert a percentage to a decimal, you always just divide by 100. That's the easiest way to do it. So 2 divided by 100 is 0.02. What about 72.5? We divide that by 100, we get 0.725. These are all representations of percentages, but just in decimal form, okay? They start in percent form, now they're in decimal form. This one can be a little misleading because it has a decimal and a percent, but I still would consider this percent form. This is the decimal form. Okay. Now, to change a decimal back into a percentage, you just do the opposite. You multiply the decimal value by 100 or move the decimal point 2 places to the right. But we're going to focus on multiplying by 100. So going from percent to decimal, you divide by 100. Going from decimal to percent, you multiply by 100. So 0.48 is now 48%, and you do need to include the percent sign. That's important. 0.03 is now 3%. If you move that decimal point twice, you get 3. And 0.835 times 100 is 83.5%. Okay? Now that we've talked about percentages and decimals and all this and fractions, what we're really trying to get at is using proportions to solve problems, because we'll have to do a little bit of that, and that's just a good skill to have. You can solve a lot of questions and a lot of problems, even in real life, by using proportions, things that are proportional to one another. A proportion, if you don't remember, is 2 fractions on either side of an equals sign. And the way the proportion works is it compares each side to the other, and it can show you what percent something is of something else. So, the general format for setting up a proportion is that on top of one of the fractions is going to go your number as a percentage. Directly below that will go a 100. On the other side, and by the way, this fraction can be over on this side. It doesn't always have to be on this side. On the other side, you take some measurement that is a part of a whole, and you put the part over the whole. Okay? So to solve these problems, you set up a proportion with x as the missing term. You'll have information that you're missing, and you put an x wherever the information is missing, because that's what you're solving for. 100 always goes in the denominator at the bottom of the second ratio, and you solve for x by cross multiplying. Remember, cross multiplying is multiplying diagonally across the equal sign. So taking this percent, multiplying by the whole, taking the 100, multiply by the part. So the example here is that 12 is what percent of 85? Oh, before I even get to that, another way to think of how to set up the proportion is that this part of the fraction stays the same. And then you see these words is and of. A lot of times in these problems, you're going to have some problems that say some number is a percentage of something else. The number that's next to the is and isn't the percent is the part. It's the same thing. The number that's next to the of and isn't the percent is the whole. Okay? So let's look at this example. 12 is what percent of 85? In other words, we have 12 out of 85 somethings, and we want to know what percentage that is. 12 is the part we have. 85 is the whole that we're considering. So we have 12 is, we have what percent, and of 85. So the way I'm going to set this up, the 12 is going to go in the is spot, goes right there. The of 85, 85 is going to go in the of spot right there. 100 always goes on the bottom of the fraction that contains a percentage. It says what percent? We don't know what percent. So that means x goes here. That's what we're looking for. Now we cross multiply. So we do 12 times 100 equals 85 times x. And now we just solve for x. So we multiply 12 times 100. That's 1200. And we divide by 85 to get x by itself. And we end up with x equals 14.12. And since that was a percentage, we're going to put the percent sign on there. Okay? So always remember the percentage sign when appropriate. We're going to do 4 more examples. 2 are right here, and then 2 we will come up with on our own. We'll write them to the side. What is 25% of 16? So this one's set up a little bit different. The is missing because is next to the what is next to the word is. And we have a percentage and we have a number next to of. So 25%, 100 goes below that. X is the is, that's what we don't know, of 16. 16 goes in the of spot. We cross multiply. 25 times 16 equals 100 times x. 25 times 16 is 400. Divided by x, or excuse me, divided by 100 to get x by itself, and we get x equals 4. Now this wasn't a percentage. We weren't solving for the percent, so we don't need a percent on there. Last one, and then we're going to come up with two others on our own. 60% is what? 60% of what number is 30? So we have 60%, we have of what number, and then we have an is 30. The of value is missing. We have our percentage, 60, directly below that goes 100. Of what number? That means that's x. The of is where x goes, and is 30. 30 goes where the is goes. 100 times 30 equals 60 times x. 100 times 30 is 3,000 equals 60x. Divide by 60. And we end up with 50. Okay, so 50 is the whole. 30% or 60, no, 30 is 60% of 50, and that's true. We have 2 more examples. Sometimes you see them like this, and this might be a little confusing to you. What is 175% of 60? And you might say to yourself, well, you can't have more than 100%. Yes, you absolutely can. If something has a 175% increase in its sale price, that means its price went sky high. It went really, really high. And in fact, it's almost doubled. Okay? So what we're going to do here is we're going to do the same exact thing. We have a percentage, so we're going to write 175 over 100 because that's a percentage. We have of 60, so that means 60 goes down here. And we have what is, so that's x. Cross multiplying, we have 100x equals 175 times 60. 100x equals 10,500. Divide both sides by 100, and you end up with 105. Okay? That is 105 is 175% of 60. In other words, it's much higher than 60. Again, if I was cutting this off, I apologize. I didn't mean to write down that low. We're going to do one more example. And it's still a proportion problem, but it doesn't have any percentages in it. It's a word problem. If I can run 3 miles in 20 minutes, how fast can I run 7.5 miles? So there's no percentage here. There's none of that here. But the trick here is to make sure that you line up your units correctly. Okay? My suggestion is to, off to the side, pick the units. We're dealing with miles and minutes. So I'm going to write miles here. And I'm going to write minutes down below. And then I'm going to set up my proportion. Oop, got that set up wrong. See ya. Okay. So my miles, I have 3 miles. I'm going to write that up here. And I also am dealing with 7.5 miles. Now I need to write minutes, but I need to make sure I have the right minutes associated with each of these. What was associated with 3 miles? Well, I can run 3 miles in 20 minutes. So I'm going to put 20 down here. I want to know how many minutes I can run 7.5 miles in. So I'm going to put an X there because I don't know that. Now I just cross multiply. I do 3x equals 20 times 7.5. So 3x is equal to 150. I divide both sides by 3, and I end up with 50. So it turns out it takes me 50 minutes, because that's the unit that we were solving for me to run 7.5 miles. Okay? So that's another example of how you can use proportions. It doesn't have a percent in it, but you do need to be able to use proportions like that. Okay? That's all the basic math review that we're going to do before we get into our really into our first unit. If you have any questions, please don't hesitate to ask me, and I will see you soon for another video. Bye.